Hello, everyone, and welcome. Thank you all for joining us today for today's session. My name is Firas, and I'm the event planner for Microsoft Reactor in Redmond. Before we start, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary and please remain professional and on topic. This session is recorded. It will be available through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I'll be sharing the link to our YouTube channel in the chat. I'll also be sharing links to the Reactor Mira page and a link to our survey since we're interested to know your feedback. Which brings us to our session today. This session will approximately go for, as I mentioned, 1 hour, and you can ask the questions throughout. Our speakers for today are Jim Bennett. He's a senior cloud advocate, and Sy Brand. He's their senior program manager at Microsoft. And now I'm going to hand it over to you.
Awesome. Thank you very much. Thank you. Good morning, good afternoon, good evening, wherever you are in the world. And welcome to this episode of Jim Learns Stuff, a show where Jim, I learn stuff. In this particular series, I'm focusing on C++. 20 years ago, I used to be a reasonably good C++ programmer, but I kind of haven't picked it up since. So today is all about me relearning C++. I'm joined by Sy, one of our developer advocates and program managers on the Visual C++ team, and it's going to be all about just diving into the language, looking at everything from a basic hello world to various kind of modern language constructs. And I'll be showing off how out of date my C++ code is, and Sy will be happily correcting me and dragging me kicking and screaming into the modern age, I think is the best way to sum it up. So that's what we're going to be all about today. So first of all, Sy, welcome. Thank you for taking time to join me on this stream. Do you want to just take a moment to introduce yourself?
Yeah, sure. So my name is Sy. I work on the C++ tools team, which is the team which deals with Visual Studio Code extensions, VC package, the compiler, the toolchain for C++. My background is in compilers for embedded systems. I've worked on the C++ standard. I've worked on compilers. I've worked on debuggers. I've spent my entire career in developing developer tools. And I got very, very into C++, like maybe 7 years ago, something like that, as part of my my job when I started working on compilers, and that's kind of brought me to where I am now. I love going to, well, I used to go to a lot of C++ conferences. Now I attend a lot of C++ conferences from here, and yeah, I'm interested to see how this goes because C++ has changed a lot in 20 years. It's gone from, a language which was intended to be used for things where performance was super critical and not a lot of thought to ergonomics and usability in terms of programming language design, or at least it would look like that from today. But now it's a much more modern language, a lot more fun to use, a lot more it gives you a lot more expressive power. So yeah, hopefully we can show some of that today.
Yeah, because I must admit, going back 20 years, I just remember things like whenever you use the standard library and you got a compiler error, it would just literally be this wall of text, and it's got no clue what that error is. So I think yeah, ergonomics is probably a great word to describe it. It was a language that it could be a struggle sometimes just dealing with some of the complexities behind it. So I'm kind of really intrigued just to see some of these modern changes. A couple of questions in the chat before we dive further. Balachandran asks, will this session be available later if someone couldn't attend the full session? Yes. So all of our Reactor streams are always recorded and they're always available on the Microsoft Reactor YouTube channel. We can drop a link to that in the chat, but otherwise just go onto YouTube and search for Microsoft Reactor, and all of our sessions are available there, usually within 24 hours or so. And Irregular Robo says, you got this. I think we got this. I think I think so. I think so. So with your brains and my typing skills, I think we can we can do something cool. So yeah, let's. I guess we should start off the way everything starts off, with hello world. So if I can just get my screen up. Oh, more questions are piling in. I haven't even got a chance to do a hello world yet, and people are excited. Lewis asked, will this tool be Windows only or cross-platform? I mean, Sy, you're on the C++ team. Do you want to lean into this one?
Sure. So Jim is currently using Visual Studio, which only runs on Windows, but you can target any platform from there. So if you have you're wanting to target Linux, then you can do that from Visual Studio. But Visual Studio itself only runs on Windows. If you are on Mac or Linux or something else, then you can use Visual Studio Code instead, which is a cross-platform editor. So there's options available for everyone, no matter where you are.
Nice. So I guess going back to Satya's any developer, any platform idea that he's been speaking about for years, you can Visual Studio very much a Windows thing. Although there is Visual Studio for Mac, which doesn't.
Visual Studio for Mac is a little bit different. Yeah, that there's not C++ support built into Visual Studio for Mac. If you want Visual Studio for Mac, well, Visual Studio on Mac, for C++, you should use Visual Studio Code.
Yeah. I mean, I'm a Mac user, and I basically live in Visual Studio Code for everything. So it's great that we've kind of got these tools available for everyone. Now, today we are using Visual Studio on Windows, and we're not going to really dive into the tools. I'll say that we're not going to dive into tools here. Next week's stream is going to be all about the tools. So this is where Sy is going to just teach me how to do everything in all the tools, and we'll look at Visual Studio Code, and just look at all the different options that you've got for tooling. So today's the language, but join us same time next week for tooling stuff. So John says, hi, y'all, excited for an educational stream. Yeah, this should be fun. I'm very much looking forward to learning stuff. Dimitri says, hello, everyone. Hello, welcome. Glad you're here. Irregular Robber says, I do C++ on Mac. So yeah, we've got folks using tools on different platforms. Excellent. Irregular Robbo, what tooling do you use? What's your IDE of choice? If we can share that, it'd be great. Great to hear what you're using. Now, I'm just going to drop a link in the chat for everyone. Just saying about tooling. This is a link to C++ with Visual Studio. So if you did want to just install it and get going today before we talk about tools next week, then follow that link. That will take you to this page here with all the stuff about how to get going with C++ using Visual Studio. Irregular Robbo uses Xcode. My condolences. Sorry. Xcode is I don't normally use it myself. I normally use it if I'm building mobile apps. I use Visual Studio on Mac, and that uses Xcode in the background. And I just hate the fact it takes about 4 hours to download and install. So yeah, my heart leans out to you every time you have to do an update. Yeah, Irregular Robbo says, LOL. Yeah, they feel my pain. Cool. You know what? Let's do a hello world. Let's actually do the hello world. Now, I will quickly say one cool thing in Visual Studio is what we call Visual Studio Live Share. So I've got Visual Studio up. I'm on my Mac, remote desktop to Windows, but you'll notice, Sy is zipping around inside my code. So Visual Studio Live Share allows people to edit the same files, run the same code in the same terminal, and as if you're literally there together at one computer with two keyboards almost. But we're in completely different continents. I'm in the west coast of the US, and Sy, you're the other side of the world.
In Scotland, Edinburgh. Yep.
Yeah, so you're literally the same time zone as where I came from. Nowhere near where I am now, but we're here editing the same file. So let's do hello world. Got a bit of code up here. I'm going to just build this code, and then I'm going to run this code, and you'll see we've got hello world.
Yay.
Now, One thing I guess to point out here is C++ is very different from languages like Python. I had to build this code and run this code. So, Sy, why? Why do I have to build and run it? Why can't I just run my code like Python?
Yeah, so C++ is a ahead of time compiled language where you take the source code, you run this through a compiler, and this spits out a binary which can then be run. So it takes your source code written in C++ and converts it into the machine code for your platform, which I assume is x64 for you. Well, I can see it in the PowerShell window there.
The x64 bit kind of gives it away, doesn't it?
Yeah, and so this allows the compiler can see all of your code, and it can spend a lot of time doing transformations and optimizations to take your code expressed for humans and for the computer and turn it into something which runs as quickly as it possibly can on the hardware which is available.
So I guess if I compare this to things like Python, for example, Python, it literally just runs the code line by line. So it doesn't compile it up front. So with Python, I can take a Python script and I can just literally run this Python script on any platform and it should just run. Whereas I can't do that with the binary, because as you said, this is an x64 binary. So it only runs on Windows x64. But so Python I can run anywhere, because the downside of Python is it's slower, because you're saying we can actually optimize this to based off the hardware I've got. So kind of we lose a little bit in the development and gain in the runtime. Is that a fair comparison, would you say?
Yeah, I mean, I think it's you can also gain in the development in some ways, in the because C++ is a statically typed language. If you have a large system, then static types allow you to reason about that system in a much more easy fashion, and it also gives you more defenses against certain mistakes. So if you have a large program, then sometimes a compiled language with static types will actually give you more productivity in the long run, because you're not spending time tracking down some of the issues which you might get from dynamically typed languages.
Yeah, I've had that where you're running a program and you have to go through a certain path and you hit a bug because you're passing an int where it's expecting a string or something.
Yeah.
But whereas in C++, it just wouldn't compile.
Yeah, exactly.
Yeah. Cool. Irregular Robo says, yay for static typing. Yeah, I must admit, I'm a huge fan of static typing. I'm the kind of person, when I'm writing Python, I'll put type hints everywhere because, I love static typing. John Yenta says, Visual Studio for Rust, when? Absolutely no idea.
Yeah, so we don't have anything to share on that yet. There are folks in Microsoft working on Rust stuff. So I think this is a watch this space.
Yeah. I keep hearing tales of various Microsoft teams moving over to Rust because it just cuts out a whole class of errors. So if we're gonna use it, we should probably make sure we've got the right tools for it. So yeah, it's gonna be interesting. Another question. It's a great chat today. Thank you everyone for questions. Matadi asks, what type of programming paradigm C++ is suitable? I know we're going to dig into this a little bit later, but do you want to just very quickly, Sy, just what type of programming paradigms is C++ suitable for?
Sure. Well, I think a lot of the time people come to C++ with maybe a couple of different expectations for programming paradigms, both of which I think are subtly not the whole story. One is that C++ is strictly an imperative language like C or something like that, whereas there's a lot more expressive things we can do in C++ because of the higher level constructs which are available to us and the ability to create high level abstractions. The second one, which is more prevalent, is that C++ is an object-oriented language. And I wouldn't say this is necessarily the case. You can do object-oriented programming in C++ if you so desire, but C++ is a multi-paradigm language. It's a very flexible language. You can do object-oriented programming, but you can also do functional programming, or have both in the same program, or and have them talk to each other, or be flexible in what you pick from different paradigms, whatever works best for your problem domain. I've seen one description I like is that C++ is a value-oriented language. That is, that an object-oriented language is concerned with the identity of objects. They are their own things, whereas in C++ you can create values. Like a matrix object is a value. You can just treat it like it's the mathematical value which it represents. And you can do this with pretty much anything because of the tools which C++ gives you. So I would say C++ is a multi-paradigm language which you can make whatever you want from.
That's a value-oriented language. Yeah, I've never kind of thought of it like that. I guess a lot of the object-oriented background comes from just the fact it was originally C with classes, wasn't it? When Bjarne Stroustrup decided to take what various learnings from Smalltalk and add it to C, you kind of took the imperative language that was C, very procedural language, and then you added classes. It was originally C with classes. So I guess that's where a lot of the object-oriented ideas come from. It must be, to my mind, it's an OO language. When we're working through, I was building out some example code for this. I was bugging in classes, and so I remember you saying, "No, we don't do that so much anymore. It's all about we do a lot of functional programming now." So I guess it's kind of a very, very powerful language we can do a lot with. But can we do WASM? Here's a question from a 10x developer. Can I compile C++ to WASM 32 from Visual Studio?
So there isn't built-in support in the MSVC toolchain. You can use things like mscripten, which is a toolchain for compiling C++ to WASM, and I've had success doing this on multiple platforms. So that's what I'd recommend looking into. I think that's still what most people do. I haven't done WASM in a few years, so there might be more up-to-date tools, but mscripten is what I used, and it was a pretty nice experience all around.
Cool. So those who have not heard of WASM is WebAssembly. So it's actually writing code that compiles but runs inside a browser. So it doesn't give you full access like compiled code, but it kind of allows you to use any language you want, compile it down to WASM, and that kind of runs in kind of a browser application, which is pretty cool. Irregular Robos, yay for static typing. Yep, we love static typing. And Lewis says, no void star here then. Oh, yes. Well, I guess we'll dive into pointers a little bit for those who don't understand that. But yes, void star is terrible. It's a pointer to some area of memory and you have no idea what it is. So yeah, 10x developer follows up with, yes, great. I already use mscripten for software already. Cool. And then, one last question. Pablo says, what kind of application I can create with C++? Now, everything, I think, is the quick answer. I know in 2 weeks' time, we're actually going to dive into that a lot more. We're going to look a lot more at some of the use cases of C++. But I guess everything.
Yeah, I would say like you can build any kind of application in C++. In terms of what applications are built with C++, anything which has runtime constraints, like it has to run a certain amount of time, has to run very fast, real-time systems, video games, anything which has a small memory footprint available to it, like embedded software, stuff running in your washing machine, self-driving cars, medical imaging, desktop applications, compilers. You can write anything in C++, and C++ is used across the industry for a huge amount of different application domains.
So the little bit of C++ I do at the moment is mainly things like embedded devices where you've got a little microcontroller in a device.
Yeah,
it needs to be compiled that small. What about operating systems though? Windows, Linux, are they built in C++?
Linux not so much, but parts of Windows, yes.
Because a lot of them are still C, isn't it? Linux is C based, isn't it?
Yeah. I'm just trying to find my I've got a keyboard which here it is. Yeah, I built a keyboard from scratch and like hand wired it, and it's got this teensy2 inside. I wrote custom firmware for it in C++, which you describe the keyboard layout and it generates you firmware at compile time. It's kind of cool.
Nice. You have all the gadgets. That's so cool. Oh, and Lubomir asks, can I create a .NET standard library using C++? Now, that's an interesting question. Can you do .NET with C++? I believe you can.
Yeah, so I'm not sure what you mean by .NET standard library, if you mean like trying to swap out parts of the .NET, like C# standard library or something like that. But if you just mean like doing interop between C++ and .NET and things like that, then yes, absolutely, you can use like C++ CLI for marshalling data across from the like managed world to the native world and things like that. There's a lot of resources out there for doing C++ .NET interop.
Because there is basically C++.NET, isn't there? So you can access all the .NET standard libraries. So yeah, but basically the whole .NET core, all those standard libraries you can access from it. And then you can build a .NET standard compatible library, can't you, in C++? Yep. So you could, if you had an existing C++ library that you wanted to make available to C# code, you could just wrap it in .NET layer, couldn't you, that's written in C++?
Yep. Mm-hmm.
Cool. And again, we're going to dive into this a bit more in a couple of weeks' time when we focus on kind of the use cases of C++. But yeah, great questions. Keep the questions coming. Although we came to this show with a plan of kind of what we want to talk about, we're very happy to kind of just go where your questions take us. So keep the questions coming. Let's keep this conversation going. It's fantastic. But yeah, let's just take a minute to look at this Hello World. Now, if I remember rightly, wasn't the very first Hello World from a C book? There's kind of this precursor to C++. Wasn't that the very first Hello World from Kernighan and Ritchie?
Could be well be right, yeah.
Yeah, I think they invented the concept. But yeah, Hello World is all about just making sure your tools work and everything works. And so this is our Hello World code. So let's kind of, I guess, can we work through this line by line a little bit and just try and explain some of these things? So hash include. I mean, guessing by the name include, this implies we're bringing something in. So this is how I use other code. Is that right?
Yep. So hash include is basically a way of getting the declarations of everything you want to use available within the file that you're currently in. So when you say hash include cstd.io, then you're saying, I want everything which is declared in the cstd.io header to be available in this file. The cstd.io is called a header file because it describes the kinds of things which the kind of programming entities, types, functions that you can use by including it.
This is kind of like an import statement in Python where you say, import IO, that says I want to have access to that. It's kind of like that. Though doesn't this do something a bit different? Doesn't this actually almost like copy and paste the code in?
It exactly just copies and pastes the code in. So yeah, there's a few components at play here. There's getting the header file available and then linking against whatever libraries that you're using. Because remember, we compile things ahead of time and get binaries out. So for the standard library, we don't have to worry about that. If you're using other libraries, then you'll need to include the header and then potentially link against something with the compiler, but we don't have to worry about that. One thing to note is that, like you said, this is just essentially copy pasting the header into this file. It's a little bit kind of old fashioned. There's some problems with it because if you have, thousands and millions of files which are all just hash including some header, and that header is very large, then the compiler is doing a lot of work to like reparse this file and things like that. So in C++ 20, there's now a feature called modules, which has an import statement. Now this is still in progress for the standard library, so you can't do like import std or something like that, but this will be becoming modules for the standard library. So modules solves a lot of the issues which there are with header files, because that was essentially just something which we inherited from C.
Yeah, and that's going back, how many years when they actually did this, because I don't know if I can navigate into it. Yeah, so this is the C std.io header file. and this is quite small. It's only 100 lines of code, but essentially this 100 lines of code is copied and pasted, for want of a better expression, into my code. And then this includes y-vals core.h and style.io.h. So again, this is copied into that file. So at compile time, isn't it, there's like a preprocessor or something that actually goes through and just copies everything into one massive, great big file. And I remember, so one of the applications I worked on many years ago had one file that was used everywhere. It's a header file, and that was used absolutely everywhere to define all the types across the entire system. And if somebody changed that file, and you then did a get from Visual Source Safe, because we were using that back then, it could take an hour and a half to rebuild. So you do an update of code, and then see that file's changed. It's like, great, I might as well go for lunch. It's fine if you do it before lunch. It's when you do it after lunch. And it's like, great, there's nothing I can do for an hour and a half while my machine just sits there and compiles. And we actually, a guy I work with, he built this whole thing where you could just avoid bringing in all the header files. It's kind of using some various pre-declarations and other weird things. I think he called it the Cheshire Cat idiom. The Cheshire Cat from Alice in Wonderland kind of just disappears, just leaves a smile. He kind of just brings in bits so that when you compile it, it doesn't take an hour and a half. So, Irregular Robo says, will modules integrate header and binary in one file?
So there's some nuances there that I don't want to get into in an introductory thing like this. The answer is sometimes.
That classic answer. It depends. Yeah. But just, I think one point to note though is that's kind of relevant to that question is I've got this .cpp file, and you're mentioning header files. When you compile up code, if you're building like a library for someone to use, you compile CPP files that have got the kind of the implementation of the code, and then you have a header file which has got like the declarations of the code. And then when someone uses that, they need the binary, because that's got the code that you've won. But they also need your header file so so their code can see what's in your binary. It's not like you can query the binary for what's there. You have to rely on the header file, don't you?
Yes, so that's how historically things have worked, and we're trying to make it more ergonomic with modules. So you can think of with the split between headers and the header file and the implementation file. The header is like, here's what my interface looks like. And then the CPP file is, okay, and here's how all of these things actually work, and here's how they're implemented.
Cool. Okay, so that's the header file. This is bringing in a whole of code. Int main. So main is our main method. This is kind of standard across most languages, isn't there? Most compile languages, you have an entry point. So this is where, when I run my code, this is the code that's run. Unlike something like Python, which is like a script almost, which it just runs through the file from top to bottom, this actually looks for this main function, doesn't it?
Yeah. So you have to have a single main function defined in your binary, and that will be the entry point to your program.
And we've got, so int obviously as an integer, we've got argc, argv, we've got this char star thing. This is one of them horrible pointer things, isn't it?
Yeah. So how we read this declaration is my function is called main. The return type of my function is int. My main function takes 2 arguments. The first one is of type int and has the name argc. This is going to be the number of command line arguments that I have been called with. And then this is an array of char stars, which are basically C style strings. So this is going to be a collection of all of the command line arguments that I got as strings.
Okay, so when you call this, if I were to call this and then pass, minus, hello, I can't spell, minus, hello world, this would have, 2 arguments, and then one would be minus, hello, and one would be world.
Would have 3 arguments, the first being the name of the program. So
okay.
the 0th argument is always the name of the executable.
Cool. Actually, I think this is maybe slightly off topic, but a lot of people do wonder why arrays start at 0. And we talk about the zeroth element, why they start at 0. And that's kind of related to C and C++, isn't it?
Yeah, well, a lot of that was from a Dijkstra paper, right? There was a paper which Esther Dijkstra wrote about why arrays should be 0-based, and a lot of it was because as you bring the bounds of an interval closer and closer together, you get inconsistencies if you have a fully open interval or a fully closed interval, things like that. So Dijkstra's observation was that starting at 0 and expressing intervals from starting at 0 and just before 5 or something is how you express the interval 0, 1, 2, 3, 4.
Okay, because I always thought it was just related to pointers. Because when you have an array, the address of the array points to the start of it, and then you add the array index in terms of the distance of the pointer. So you're when you have an array, literally it points to a block of memory. So say you've got an array of 10 integers, they take up 10 integer-sized blocks in memory. So each integer is going to be 4 bytes. You've got 40 bytes of memory continuous, and then your array just points to the very first element there. And so your first element has got an offset of 0. It's that memory address, and then your first element you add 1 times the size of the thing. So you kind of just literally offset your memory by the array index times the size of the thing in memory. So I always thought it was places that, but I guess I haven't dug into. This is why I don't have a degree in computer science, and you do.
Yeah. I found a link to that Dijkstra paper. I pasted it in our private chat, so if you want to send that out to folks, it's a very short paper. I'd recommend reading it. It's like it'll take you. It depends on how your maths is, but it's like a page long or something. I would recommend reading this paper if you've ever wondered why numbering should start at 0.
Okay, that's I need to educate myself even more. So yeah, I'm going to be reading that one later. So we just dropped that one in the chat there. Now, Surly Dev asks an interesting question. You could enable certain behaviors by renaming the exe of your app and then checking the 0th element in your code. Sneaky.
So I think that some production programs actually do this. I might be wrong, but I think that so if you run Clang, which is a C++ compiler from the command line, there's the Clang binary and there's the Clang++ binary. The Clang binaries for C, the Clang++ binaries for C++. And I think that at least at some point they have been exactly the same binary. They've just been symlinks to exactly the same thing. And the compiler driver works out if you're wanting to compile in C mode or C++ mode based on the name of the executable which you called. I don't know if this is still the case or if I'm completely wrong, but I think that has been true at least at some point.
That's quite cool, actually. Yeah. So if you could just you could have the same tool, different names. Yeah, it's only one code base to maintain, or your build system just spits out 2 different named things, and then you just check at the runtime. Yeah, that's really cool. Cool. Okay, so we're half an hour in, and we've got as far as int main. This is how these things go. Some great discussions. So thank you everyone for your comments. Please keep chiming in with questions. Really enjoying this. So we kick off stud : printf hello world. I guess this is our actual hello world. This is the bit where we say hello. So what's this stud : all about? I guess printf is to print to the console, same as print in Python, but what's that?
Yep. So stud : is what's called a namespace. So if, say, I want to write a function called doThing, which does nothing, so maybe it should be instead called doNothing. I can only have one of these in my entire program. So if I write a doNothing function and then someone else comes along and writes another function, or maybe I have a library which I use, which also has a doNothing function, which happens to actually do something, then bad things are going to happen, right? So C++ has namespaces. So I can say, this is my do nothing. And then when I want to call this, I use my do nothing. And this will ensure that I'm using the one which I meant and not one which is somewhere else in the program.
Cool. Okay. So this stud printf is saying, because if anyone's done C, they would have used printf. That's just the normal way you print out the standard output. But so stud printf is a new version of printf that's part of the standard library.
It is the same thing as cprintf. It's just in the stud namespace.
Right. Okay. And that prints hello at the console. And then we return 0. Now, again, for folks used to languages like Python, you just stop. But we've actually got to return a 0 because this main is an integer value, isn't it? So what's that all about?
So the return value of main is the error code, which will be handed back to the operating system. So, if you're running on the console and you can you run the program and you can check the error code to see if it failed or something. So if you return 0, then this means everything was good. You don't actually have to return 0 from main. This is a special case in the language where if you fall off the end of main, it returns 0 by default. This the only place in the language that happens. So these two programs, with or without return 0, are exactly the same.
I did not know that was implicit. So I'm going to delete that return 0 and I'm going to build this. And I'm going to, it builds. Yeah, it didn't complain. I'm going to run this and it works. That's pretty cool. So for any other function, I'd have to return, but main has got that magic.
Yeah.
Cool. So Surly Dev says you can use error level in command line scripts to check the result of an exe. Okay, I've not come across that because I know if you run an executable, you do get an error, and kind of going back to sort of Unix days where you would chain a whole load of executables together, and if one failed, the output of that would be -1 or whatever, and you could see everything failed. But do you know anything about error level?
Yeah, I mean it depends on what operating system you're using and what terminal you're using. So like if you're using Bash, then you'd use the $! Whatever, and error level I think is a CMD thing.
Yes, yeah, some Windows.
Yeah.
So okay, so error level is like an error that's reported to the operating system by the code.
Yeah.
Cool. Okay. And Fefehara says I'm using namespaces in C++ and it's very useful.
Yeah, it's just a good way of organizing your code as well.
Because I guess if you structure it in namespaces, it's like building lots of little libraries together. You can almost think of a namespace like a kind of a named library with everything in for mentally dividing up your code.
Yeah. Mm-hmm. And you can have them, they can be nested as well. So like if you have my namespace and then maybe you have special stuff. This is where your really good functions go. So this is my good function. Then you could call this by saying my special good function. And if you find yourself like needing to use many different things inside my special namespace, then instead of repeating my special in front of every single thing, then you could say using my special. And that just makes everything available so that you don't have to prefix it. So now I can just say good function.
You see that a lot of you see a lot of C++ code that have using namespace stud at the start because stud is kind of used everywhere. So
yeah, I try to avoid that personally, but I tend to try to just have using namespace on like inside functions or maybe at the top of a file if it's my own namespace. I try to avoid using namespace stud.
So I guess it's one of those things where you want to have good code analysis tools as part of your build process. Because if you've got a team of 4 or 5 different people, and one person likes to put using namespace stud at the start of their files, and the other person doesn't, you've got to make sure you kind of got that consistency of code style when you're working on large projects.
Yep.
So Irregular Robo asks, does using namespace honor scope?
So if I had another scope inside here and I said using namespace, my special inside here, then I could call good function like so. But if I tried to call good function here, then this wouldn't compile.
Cool. Okay, so yeah, so it's at the scope of so scope, for those who haven't come across it, it's kind of it's if you're inside a function, you do it. It means that just applies for the rest of that function. If you're inside, a file, it just applies to that file. Though I guess with like the header files, if you were to put using namespace stood in a header file, and then someone else brings that header file in, because it copies and pastes everything in.
Yeah, don't put using namespace inside a header file.
Because if someone uses your header file, they get that using namespace throughout their entire application, potentially. Yeah. Okay, so Lewis got another question. Shouldn't you need void main instead of int main if you're not returning?
Yeah, this is just that special case. It's just the compiler pretends that you wrote a return 0 here just for main. So you still need it to be int main. If you wrote void main, it wouldn't compile. Okay,
so I guess this is probably a time for a great question on this then. What is void? You say void main. What is void?
Void basically void means different things in different contexts sometimes, but it broadly means nothing. So if I say void do nothing, it means I don't return a value. I'm a function which is only executed for my side effects, not to compute anything.
Right. So this would be the same as in other languages where you just don't put the return type.
Sure. Yeah.
Void. Okay. But there's other uses of void, isn't there? You can be used in like somebody mentioned a void star earlier on. That's where you can have that means it's a pointer to it's something in memory. I just don't know what it is.
Yeah. So that's kind of why I said that void means different things in different contexts, because void on its own means anything. Void star really means anything. So it's kind of confusing. I wouldn't think about void star at the moment. Just think about void. Void as a return type means I don't return a value.
Yeah. Cool. Irregular Robo's just going back to our comments about the namespace and header files. Kind of a bit of a brain explosion there, and did not consider that. Yes, that's kind of that's one of the weird things about header files is the fact that anything you do in a header file affects every single file that uses that. And of course, if a header file is used by header file used by header file used by code, you could put something in a header file that impacts so much of your code. Like I was saying earlier, you make one change and that's an hour and a half to rebuild everything because every single file changes. It's kind of some big side effects. So Surly Dev asks, void is the VB equivalent of a sub, isn't it?
Yeah, I haven't done Visual Basic in a very long time, but from memory, function returns a value and sub does not return a value. So, and if that is true, then yes, void is.
Yeah, I think that's right
because of a sub.
Yeah, because the difference between going back to the difference between a function and a subroutine. A subroutine is just something that runs, whereas a function does something and returns you something. So yeah, I guess VB. It is the VB equivalent of a sub. Wow, let's go back. Surly Dev, are you a VB programmer at the moment? Be great to know, because I know this VB.net, for example, has a small but very, very happy audience. So it'd be great to find out if you're a VB.net developer. So Fefe Hara says, I love C++ because I work with voice technologies and I have a lot of libraries in C++. I'm migrating to modern C++, many libraries, but my company friends use .NET Core. I don't know if anything has changed, but C++ CLI doesn't work in Linux environment with .NET Core yet. I need to interrupt in C#. Okay, I haven't done much of that. And I know in a couple of weeks, so we're going to be focusing on use cases, so we can dive into .NET a bit more then. But yeah, I mean, in theory, everything C++ should work with .NET Core. Again,
I haven't really worked with C#, like C++ CLI stuff in non-Windows environments. So yeah, I'm sorry, I don't have a a good answer for you there.
Okay, maybe one we can play with in a couple of weeks' time when we look at use cases. So go back to VB questions. So Surly Dev says, not at the moment, no. So not a VB developer, but I do dabble in it now and then just for fun. So yeah, certainly VB was a fun language when I remember using it back in the days, like VB6. Just the whole
I did VB6 at high school.
Yeah, it's great. Drag some buttons on, double click it, add the event handler. Very productive. Yeah, this is kind of when everyone used to talk about RAD, rapid application development. And that's going back some. Cool. Okay, so back to our hello world. Just going to think about sort of data types a little bit. We talked a little bit about ints and char stars. So in terms of data types then, we can just declare things like an integer and a float. The same as in a lot of languages, we just declare here is an integer, here is a floating point number. That's kind of all fairly standard for folks who don't know any other programming languages. But strings, you mentioned about char star as kind of a way of doing a string. I know of two ways of doing strings. And then let me just copy and paste some code in. Oh, sorry, I need to put a constant there, don't I? Do we need to put a constant there? Yeah. So there's two ways of doing strings here. We've got a char star and a std string. So why?
Yeah. So this const char star is basically pointing to, this string will be embedded somewhere in the binary. And this is essentially a pointer to exactly that memory. When you're starting out, I would mostly forget about char star. Like you will see it some places and you should know that it usually means this is a string, but you shouldn't be playing around with them generally. Instead, you should be using a std string. A std string is a type which manages the memory of the string automatically. So, I can take this thing, I can make it bigger, I can add more, like I can say hello plus equals exclamation mark to add an exclamation mark to the string. Sorry. Yeah. You might notice I had there's double quotes and there's single quotes. Double quote is a string, single quote is a character. So this std string, I can make it bigger, I can add things to it, whatever. This const char star, I can't do anything with. Like Dennis says in the chat, there is this new thing in C++ 17 called string view, which is a non-owning view of a string. So std string manages its own memory and you can add to it and do whatever you want. String view is something which just looks at some string from somewhere else. Right.
Okay. So a std string is kind of closer to the string type you would get in a language like Python or .NET.
Yeah.
Essentially. Whereas a char star, this is kind of going back to the C days where you didn't have a class that could do it. It's literally, here is a block of memory with a string in it. And I'm pointing to that block of memory. And if I read past that block of memory, we have problems. And I guess this is kind of leads to some of those security issues. When people talk about like a buffer overrun vulnerability, this is because you could, if you wanted to store something as a char star, essentially you have to say to the operating system, I need a block of memory, and I'm going to put something in this block of memory. And if you ask the operating system for a block of memory of 1,000 bytes, but you put 2,000 bytes in there, where does it put the remaining 1,000 bytes? It can kind of just, it can essentially overwrite memory, can't it?
Yeah.
So this is kind of why char stars are dangerous, whereas std strings are less dangerous.
Yeah, not that you can't get into troubles, but a lot less trouble. Irregular Robus asking, how is std string view different from const std string? So std string view has to point to a string which already exists. So I can point it to this thing because this thing is going to be stored in the binary somewhere. This here will create a copy of what's stored in the binary and store it inside here. So even if I say this is const suds string hello, I can now no longer modify this, but it is pointing to its own copy of this data.
Okay, you're using the word const there. I know I dropped const in earlier. What is const?
Const means constant. It basically says you cannot modify this.
So I couldn't come along and go, hello equals goodbye.
Yeah, exactly. That would not compile.
It wouldn't like that because, it's put a no operator equals matches these operands. Operands types are constant string as const chart. Okay, so there's literally something there that says I cannot. There's just no code to do this.
Yeah,
it doesn't work.
Exactly. Yeah, this is potentially one of the defaults, one of the many defaults which C++ got wrong, and that some more modern languages like Rust say that constantness is default, and you have to opt in to mutability. C++ is the other way around.
Yeah, which because a lot of functional programming is all about immutability. So by default, everything's immutable. You have to mark, like use F#, for example, the functional version of .NET. You've got to mark things as mutable if you want to change them. Here, everything's mutable by default. A regular robo says, the C++ equivalent of const char star. So so std string view is basically a const char star, but where being a class, you've got more stuff you can do with it. It's not just a pointer. There's functions you can do to substring or what have you. Things like that.
And it also tracks it also keeps track of the size. So a const char star, you don't know how big that string is without checking the memory essentially, or having the compiler work it out for you. Whereas a std string view stores the size of the string at runtime.
Yeah, because a const char star, essentially you allocate a block of memory. So you might say, I want a const char star that uses 256 bytes of memory, and then you actually define the length of the string by having a 0 on the end, don't you? It's what's called like a null terminated string.
Null terminator,
so,
yeah.
So if you've got 256 characters in there, and your string is only 10, is hello world, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 characters, and then the 12th character would be a 0.
So you can even see there when you're hovering over it says const char star size 12 because it's taking into account the null terminator.
Yeah, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then behind the scenes it adds a 0 value, and not a 0 as in that, but a 0 as in these strings are stored as like a byte essentially that maps to ASCII, which is the mapping between byte values and letters, and there'll be a 0 ASCII value on the end. So if you actually look at the raw binary data, it would be, this would be 56, and this would be 43 or whatever it is. But then that would be a 0 on the end to say that it's null terminated. So I guess we're diving a bit into memory. I know we're probably zipping around our plans because we've had some fantastic questions. So thank you everyone who's been diving in the chat with some great questions. This is really fun. But I think maybe we should zip ahead and talk a little bit about memory. We keep talking about memory and pointers, and that's kind of part of what makes C and C++ both very powerful and very scary languages, is that you can allocate memory. So I could say int star my int equals new int. So I can literally allocate a block of memory and say, this is mine. I hold a pointer to that block of memory, and then I can actually pass this around, couldn't I? So I could have a void thing int star val like that, and then I'm just passed it, literally just a pointer to the block of memory. So rather than pass the whole integer around, or big object, I could literally just get past its address inside the memory of the computer, and I can do things with it. And then when I'm finished, I can go, I can call my thing, for example, with my int. And then when I'm finished, I can delete it, can't I? I can say, clean up all my memory. Now, this is kind of the classic C++ that I grew up with. And I imagine you're probably horrified right now.
Yeah, this is very much not how we tend to do things these days.
So I mean, it's kind of a great idea that if I want to, I've got a thing. If this thing takes up a whole load of memory, I've got like an instance of a class or a big block of binary data that takes up a whole bunch of memory. I can just say, allocate me some memory, put the stuff into it, and then I just give out the address to various functions. But this could all go wrong, couldn't it? There's lots of bad things that could happen. So how do we do this in the modern world? How do we deal with pointers and memory and all that in modern C++?
Yeah, so the most modern C++ way to do it is to not do it at all. If you can keep all of your objects just as regular, automatically scoped variables, then everything tends to work a lot better. In the times where you do need to dynamically allocate memory, which is, if something needs to change size at runtime, or you need to have like a graph structure or all of these things, then we have a bunch of different ways to deal with that. One is using the standard collections, such as instead of keeping around an int pointer and allocating enough memory for a bunch of ints and then dealing with all that memory yourself, then using a std vector of integers, which is like a dynamically sized list of whatever type you specify here. And then if you still can't use collections, you can't keep your variables as just regular variables, you actually do need to dynamically allocate something, then there's what's called smart pointers. So one of the worst things in this is here, this delete keyword, because you could forget to do this. And if you forget to do this, then there's not really much problem here because we're allocating a single int, but maybe this happens a billion times in your code within a few seconds. Suddenly you're in a massive problem because you will run out of memory. Another problem is calling delete myInt twice, which you might think, well, that's obvious, just don't do that. Well, the problem is this thing could get passed around in so many different parts of your code, and if somewhere deletes it and then somewhere completely different written by someone else deletes it again, then you get into problems again. So basically you want to call new once and then delete it once, and this is a surprisingly difficult thing to do. So what we have now is ways of doing it automatically. So if you say you have a unique pointer, which is basically something which says, I am a pointer to some dynamically allocated thing, and I'm going to handle the memory. Don't worry about it. So now we have myInt, and we can say std make unique, which will create a unique pointer to an integer. And now we don't have to call delete. We could say thing myInt get if we really want to get the raw pointer. But now we don't need to call delete. When we get to the end of the function, delete will be called automatically on this unique pointer. And if it's inside some if block, then delete will be called here at this point. So basically yes, it's scoped. So as soon as this variable goes out of scope, then the memory which it points at will be reclaimed. This has been available since C++ 11.
Yeah, regular Robo's asking that question. How long has it been available? Because they say, until you've dealt with memory pointers in Swift, you've not seen scary yet. So, Lewis says, I think it's C11 or C14, so a little while. So yeah, C11, you say. And I guess just for those who've not come across the naming, it's based off the year, isn't it? So C11,
C++ 11, C++ 14, 17. Yeah. So we're now on C++ 20 has been released, and C++ 23 is coming up next.
Cool. So Tiger Cubby asks, what's the difference between unique and shared pointer?
So unique pointer, one of the things about it is in the name, it's unique. You cannot say std unique pointer int my other int equals my int. This will not compile. You cannot make a copy of this thing because you want to make sure that, how many times do I call delete when I get here? You need to the runtime system would need to keep track of all of that stuff. So it doesn't do that. Unique pointer tries to be as low overhead as possible. So the question from Sebastian there, is there any considerable overhead while using unique pointer? No, not really. Unique pointer is tries to be as low overhead as possible. And one of the ways it does that is in making sure that you can't make copies of it. You could, if you need to move this somewhere, then you could use std move, which basically says, I want to steal the memory which this thing has used.
So as Q Ultima says, unique is if you want to use it for one pointer, so use it in one place.
And then if you want, there's a question on what's the difference between shared pointer and unique pointer. Shared pointer, if this my int thing was a shared pointer instead, and I did make shared here and shared pointer here, then I could make a copy of this, and what it would do is maintain a reference count. So yes, exactly that. Irregular robot just asked if shared pointer uses reference counting under the hood. Yes. So every time you make a copy of the shared pointer, then it will increment the reference count, and every time one of these things is destroyed, then the reference count will get decremented. So if I open up a new scope here, then here our reference count is 1, here it's 2, after this it's 1 again, and after here it's 0, so the memory is reclaimed.
Nice. Remember Objective-C was all about reference counted smart pointers. So this kind of similar idea is counting under the hood. So yeah, Sebastian asks, unique pointer requires a bit of knowledge of move semantics as well, right?
Yeah, so move semantics there is referring to when I did std move back here. So in general, you don't need to know a huge amount about move semantics, just to note that if you want to steal the memory which a unique pointer is pointing at, then you need to move it.
Cool. And Onion says, just use Rust or Haskell. Don't use this messy C++.
I mean, one of the things is that this is kind of messy, but this isn't how we write C++ these days, right? We have much more modern ways of dealing with this. Like I said, the best way to do this stuff is to not do it. And we have a lot of facilities available now to make sure that you're not doing it. So like you like Rust's iterators and things like that. Great. We've got ranges in C++ 20. That doesn't give you necessarily feature parity with everything. But if you have existing C++ code bases, you're using C++ libraries, then it's a great option.
Cool. Yeah, we're not going to get time to dive into that. Unfortunately, we are kind of a few minutes over time. So hello, everyone who's watching on Twitch and is expecting the next show to begin. So yeah, no, this has been great. Some fantastic questions. Irregular Rubber says, I'm eager to learn how to C++ without pointers.
Yeah, I mean, that's the goal, right? Yeah, C++ without pointers, trying to avoid them as much as you can because they cause problems. And we have a lot of great facilities for doing that now.
Yeah. Tiger Cubby says, I love Rust, but it's too young. Third-party library is not as established and math syntax is a bit inconvenient. Yeah, so in C++, there's so much libraries out there. There's how many, 30 odd years, 40 years of great stuff you can use. Awesome. Well, we do need to wrap up there, unfortunately. This has been brilliant. Thank you, everybody who's been involved in the chat. I'm going to just drop a link in for everyone, which is to our C++ landing page for how to get going with C++. So we have a whole of documentation on the language, not Microsoft tooling, but the language itself. So there's all the stuff in here about all the new cool bits and pieces. And then I'm also going to drop in one more link to, if you want to dive into some more cool stuff, Sy actually ran an event recently, Pure Virtual C++. Drop a link to that in the chat. There's conference that was run a couple of weeks ago. All the sessions are available online to watch. But otherwise, yeah, thank you, Sy, for taking some time to join me.
Thanks for having me.
Thank you, everybody who joined. Thank you all for your questions. Next week, we're going to dive into the tooling. So we're going to be looking a bit at Visual Studio Code, running the compiler, how to use other people's code, things like that. But otherwise, yeah, thank you all for joining this session. I really appreciate you taking the time.
Thanks, everyone.
And I will just say, actually, one quick one before we go. We do have a survey. Please fill in the survey. When you go to aka.ms/reactor/survey, it will ask you for an event ID so that we know which session you're commenting on. And the event ID is 16128. We love your feedback. We want to know whether the streams we're putting on for you is what you want. So this is kind of your opportunity to say, I like this, didn't like that, more of this, less of that, and just help us guide you in, or help you guide us to making sure we create the content that you want. And yeah, Q Ultimus says, very interesting stream. Hope you guys have an amazing day. Yep, no, thank you all folks who are watching. Hope you have an amazing day. Sy, thank you very much indeed.
Thanks.